Alrighty, let's get into our next lesson on system of equations, where here we are going to review the two different methods that we have learned to algebraically solve systems of equations. Of course, we can solve them using the graphical method, but then we would need a graph, which most of the time on the readings were not given. So we're going to learn how to do it either the substitution or the elimination method. Remember, substitution method says you need one of the variables to be x equals or one of them to be y equals, and then we could substitute in. So here, this equation already says y equals, so I can erase y in my other equation. So I know that y equals 3x. So I'm going to rewrite the second equation. 5x plus 2, instead of y, I'm going to put 3x equals 22. And I'll have 5x, 2 times 3x is 6x, equals 22. 5x plus 6x is 11x, equals 22. And to get rid of the 11, I'm going to divide, and I get x equals 2. Now, once I know what x equals, I need to go back and also find what y equals. So, I'll go to the first equation. Y equals 3, x is 2, which 3 times 2 is 6. Let me double check that this is correct. 5x we found is 2, plus 2, y we found is 6, hopefully equals 22. 5 times 2 is 10, plus 2 times 6 is 12, and does that equal 22? 10 plus 12 is 22, which equals 22, so we are good. So our answer here is x is 2, and y is 6. Nice job. Alright. Now let's look at problem 2. We are also going to solve this using the substitution method. How do I know that I can use the substitution easily here? Because x is already equal to something. So I easily plug in for x. I wouldn't want to use the elimination method here because then I would need to get the equation to say x plus y equals the constant. So 2, instead of x, I'm going to put y minus 2 plus 3y equals 21. 2 times y is 2y, 2 times negative 2 is negative 4, plus 3y equals 21. Now let's combine like terms. 2y plus 3y is 5y, minus 4 equals 21. Add 4 to both sides. I get 5y equals 25. Now to get rid of the 5, I'm going to divide by 5 on both sides, and I get y equals 5. Perfect. Now I need to go find what x equals. So let's go to the first equation. X equals 5, which is y, minus 2. And 5 minus 2 is 3. Alright, let's use the second equation to make sure that this is correct. Alright, 2, instead of x I'm going to put 3, plus 3, instead of y I'm going to put 5. And does that equal 21? Let's see. 2 times 3 is 6. 3 times 5 is 15. And 6 plus 15 is 21. So 21 equals 21. We are good. So our ordered pair would be x is 3, y is 5. So 3, 5. Nice job. Now we are going to do 2 examples with the elimination method. Alright, let's look at this first one. Alright, to use elimination method, I need to get both of these equations to have the same, one of the variables have to have the same coefficient where one's negative and one's positive. I'm going to times the first one by 2 and the second one by 4. And I'll make the second one negative, doesn't matter which one's negative. 2 times 4x is 8x, 2 times negative y is negative 2y, and 2 times 10 is 20. Then negative 4 times 2x is negative 8x, negative 4 times 3y is negative 12y, and negative 4 times 12 is negative 48. Alright, let's solve this. Negative 8x plus 8x crosses off. Negative 3 minus 12y is negative 14y. And 20 plus negative 14 is 20 minus 48 is negative 28. Now let's divide by negative 14. And I get y equals 2. Nice job. Alright, let's go to the first equation and find what x equals. So I'm going to have 4x minus my y is 2 equals 10. Add 2 to both sides. I get 4x equals 12. And to divide by 4, I get x equals 3. Now I'm going to use the second equation to make sure this is correct. So 2 times x is 3 plus 3, y is 2 equals 12. 2 times 3 is 6, plus 3 times 2 is 6. Hopefully that equals 12. 6 plus 6 is 12, so 12 equals 12. We are good. What is our answer here? 3, 2. Nice. Alright, let's look at this one. I need to make the coefficients the same in order to get the variables to cancel out. So I'll multiply the first one by 3, since that is my coefficient of the b in the second equation, and then I'll times this one by 4. If I just did that, I would get 12b and 12b. I need one to be negative, so I'll make that negative. 3 times 4b is 12b. 3 times negative 8 is negative 24c. And 3 times 24 is 72. Okay, negative 4 times 3b is negative 12b. Negative 4 times 2c is negative 8c. And negative 4 times 2 is negative 8. Alright, 12b plus negative 12b is 0. Negative 24 plus negative 8 is negative 32c. And then 72 minus 8 is 64. Now let's divide by negative 32, divide by negative 32, and I get c equals negative 2. Alright, now let's plug into the first equation. 4b minus 8, instead of c I'll put negative 2, and does that equal 24? Well, now we have to solve. It does equal 24. So we have 4b, negative 8 times negative 12 is positive 16, equals 24. Let's subtract 16 from both sides. I get 4b equals 8. Divide by 4, I get b equals 2. Now let's check this using the other equation. 3 instead of b I'll put 2, plus 2 instead of c I'll put negative 2, and we hope that that's going to equal 2. 3 times 2 is 6, 2 times negative 2 is negative 4, 6 minus 4 is 2, and does 2 equal 2? It does. We're not going to use an ordered pair here because we don't know if b or c should come first, so it's just b equals 2 and c equals negative 2. Alrighty, nice job, nice job. Now, on the warm-up, we solved 2 systems using substitution and 2 systems using addition/elimination. While you can always use either method with any system of equations, some are set up to be solved more quickly by substitution, while others are more quickly solved by addition. Today we will compare and contrast these 2 methods. Look at each of the following systems of equations and decide if you would use substitution or elimination to solve it and why. You do not need to solve them. Alright, right off the bat, I see here that I'm going to use the substitution method. And why? Because one equation is solved for y. This means that if I wanted to plug this in, I could easily plug in what y equals, which is the 5x. Alright, let's look at this one. Ooh, here I would love to use the elimination method. And why is because y and negative y would cancel out. You could have also said that you would like to use the substitution method because it's easy to solve one of the equations for y equals because the coefficient is 1. Let's look at 3. Ooh, 3. This one, you can say that you would like to use the substitution method because it's easy to get one of them to be x equals or y equals. But here I think the elimination method is even easier. And why? Because the y's would eliminate. It would be easy to eliminate the y since we have a positive 1y and a negative 1y. Let's look at number 4. Here I'm definitely going to use the substitution method. And why? Because one variable is solved for x. Meaning we could just plug in what x equals to the second equation. I meant to say one equation. Alright, let's look at this next one. Number 5. Number 5, I like the substitution method. I definitely spelled that wrong. Okay, fine. Substitution method because the second equation is solved for a, making it easy to just plug in what a equals. Alright, this next one. Alright, so I know that it's not going to be substitution method because I don't see any of the coefficient have 1, so I'm going to use the elimination method. And why? Because it would not be easy to solve for x or y, since the coefficients aren't 1. Here I will again use the elimination method. 2 reasons. One, because again it wouldn't be easy to solve for x or y equals since no of the coefficients are y or 1, and also because it is already set up to easily add equations. Alright, this next one. I will say we can use the elimination method or the substitution method here, but maybe I'll use the substitution method. And why? Because I can easily solve first equation for x, since coefficient is 1. Over here, again, we could use the substitution method if we wanted. And why? Because can get first equation x or y equals, since coefficients are 1. But you could also say that you would use the elimination method since they're already set up easily to add these 2 equations. And this last one, I'm definitely going to use the elimination method because I just have to make 1x negative 7 and the x will get eliminated. Nice. Alrighty, so now let's solve these system of equations using any method we want. Here for this method, I'm going to use the elimination method since it's already set up to be eliminated since both equations are x plus y equals a number. Also, I wouldn't want to use the substitution method since neither of the coefficients are 1. So I'm going to multiply this one by 2, this one by 5, And I don't need to make either of them negative since they will easily cancel, since one's already negative. 2 times negative 5 is negative 10x. 2 times 3y is 6y. And 2 times 12 is 24. Then 5 times 2x is 10x. 5 times 5y is 25y. And 5 times 11 is negative 55. Then negative 10x plus 10x cancels out. 6y plus 25y is 31y. And 24 minus 55 is negative 31. Divide by 31, divide by 31, I get y equals negative 1. And now let's plug into the first equation to find our unknown. Plus 3, I know that y is negative 1 equals 12. That will give me negative 5x. 3 times negative 1 is negative 3 equals 12. Plus 3 on both sides. I get negative 5x equals 15. Divide by negative 5, I get x equals negative 3. Let's use the first equation to make sure, the second equation to make sure this is right. 2x is negative 3 plus 5, y is negative 1, and let's hope that equals negative 11, which it does. So x is negative 3 and y is negative 1. Nice job. Alright, let's go to the second example. Here I'm going to use the substitution method since it's already x equals, and I could easily substitute in. So 5y minus 4, x, I'm going to make it y plus 4, equals negative 25. That would give me 5y, negative 4 times y is negative 4y, negative 4 times 4 is negative 16, equals negative 25. 5y minus 4y is 1y, minus 16 equals negative 25. Add 16 to both sides. I will get y is equal to negative 25 plus 16. I get negative 9. And now let's plug into the first equation to find what x equals. So x equals y is negative 9 plus 4, meaning x equals negative 5. Let's use the second equation to make sure this is correct. 5, instead of y, I'm going to put negative 9. Minus 4, instead of x, I'm going to put negative 5. And we need this to equal negative 25, which it does. So negative 5, comma, negative 9. Alright, nice job. Now you are going to try these 4. You're going to choose which method you think would be the best, either substitution or elimination, and solve these 4 equations. Nice job.